You know, our coastlines are never really static, are they? They're constantly being reshaped by waves, tides, and of course, rising sea levels. But how on earth do we actually measure these changes accurately? Well, today we're going to dive into some incredible open source tools that are completely revolutionizing how we keep an eye on our planet's shifting shores.
All right, here's what we've got on tap. First, we'll talk about why our changing coastlines are such a massive issue. Then we'll dig into how scientists map these shifts and introduce a fantastic new tool called QSCAT. We'll check out its features, see how it's being used in the real world, and wrap it all up by looking at what this all means for the future of our shores.
So let's just jump right in. We're starting with the fundamental challenge here. Our world is always in motion, but that is especially true right where the land meets the sea.
So here it is, the big question. How do you measure a disappearing beach? It sounds almost like a riddle, but it's a huge, huge challenge for scientists and coastal managers. You can't just go out there with a tape measure, right? You need to track the shoreline's position over years, sometimes even decades, to really understand the trends.
And listen, this is not just some academic exercise. This data has direct, real-world consequences. We're talking about defining legal property lines, predicting where hurricane flooding is going to be the worst, managing erosion to protect whole communities, and monitoring the health of vital resources like our wetlands.
Okay, so how do we actually get our hands on this crucial data? Well, the answer lies in turning these vast amounts of satellite and aerial pictures into precise maps that we can actually use.
You see, coastal erosion isn't just a local problem, it is a global threat. And to fight back, experts rely on a process called Shoreline Change Analysis, or SCA for short. It's really the systematic science of figuring out how and why our coastlines are on the move.
Now, this whole process might look a little technical, but it really just boils down to 4 key steps. First, you have to clean up the raw data. And that's data from satellites and from LiDAR, which uses lasers to create these incredibly detailed 3D maps. Second, the software is trained to automatically tell the difference between land and water. Third, those shapes get refined to remove any errors, like maybe a boat or a cloud got in the way. And finally, that boundary is traced to create a clean, usable shoreline map. And that's how raw data becomes actionable intelligence.
For years and years, this kind of analysis required really expensive, super specialized software. But that's all changing, and it's thanks to a new generation of open source tools. So let's meet the star of today's explainer.
This is QSCAT. It stands for QGIS Shoreline Change Analysis Tool. And what it is a completely free, open-source plugin that works with QGIS, which is a super popular mapping platform. To put it simply, it's a specialized toolkit built to do one thing exceptionally well: analyze how shorelines change over time.
Now, to really understand why QSCAT is such a big deal, it helps to know what came before it. It builds on the foundation of an older tool from the U.S. Geological Survey called DSAS. The folks who developed QSCAT basically took that core idea and just focused on making it way faster, much easier to use, and a whole lot more efficient. It's a true evolution.
And when we say faster, we really mean it. Research has shown that QSCAT's overall speed is a staggering 8 times faster than its predecessor. Now, for a researcher, that is a game changer. It means you can study much larger coastlines, get results way faster after a major storm, and run more complex scenarios without tying up your computer for days.
So, we know it's fast and we know it's user-friendly, but what kind of analysis and what kind of outputs can you actually get from QSCAT? Let's take a look under the hood.
Well, QSCAT gives you a whole suite of analytical tools. It calculates key statistics like net shoreline movement, which is just the total distance a shore has shifted, and the endpoint rate, which is the speed of that change. It can also calculate the total area of land that's been lost or gained, and what's really cool is it can even forecast where the shoreline might be in the future, and it visualizes all this data on a map before generating a full report.
So what does all this mean in practice? It means users can pinpoint the most critical erosion hotspots that need immediate attention. They can put a hard number on just how much beach has disappeared. And they can use those forecasting tools to plan for the future, helping to make our coastal communities more resilient.
This is where the story gets really exciting. Because QSCAT is free and open source, it's not just for elite research institutions. It is, quite literally, science for everyone. And getting started is incredibly simple. If you have the free QGIS software, it's just a few clicks to find and install the QSCAT plugin. This accessibility is really its secret weapon.
And you can see who's using it right now in the real world.
This is a real post from a master's student on Reddit. They're not just asking a hypothetical question, they are actively using QSCAT for their thesis research. This tool is empowering the next generation of scientists as we speak.
You know, unlike commercial software that you buy off a shelf, QSCAT isn't a static product. It's a living project. It grows and improves because the community of people who use it are also the people who help make it better.
You can see this collaboration in action right on the project's GitHub page. This is where users can report bugs they find or suggest new features. The developers actively welcome this feedback, making it a priority to improve the tool's stability and power for the entire community. So, what does a tool like QSCCT mean for the bigger picture, for the future of protecting our coastlines?
Ultimately, what QSCAT does is it democratizes the science. It takes this powerful analytical capability out of the exclusive hands of major institutions and puts it into the hands of anyone with a computer. We're talking students, local governments with tight budgets, and researchers in developing nations who are on the front lines of climate change.
And that leaves us with a final thought. In a world where our coastlines are under more pressure than ever before, the power to analyze, understand, and predict change is absolutely critical. By making that power accessible to everyone, tools like QSCAT aren't just changing the science, they're changing who gets a seat at the table to protect our shores.